up to looking at the processes and information around installing an operating system. We're looking specifically, when we're talking about the syllabus, your ability to understand the processes and procedures for installing, configuring, optimizing, and testing an operating system. We're specifically looking at the key heading from the syllabus, installing an operating system today. We start with what are the minimum and what are the recommended requirements for software. The minimum requirements, obviously, are the absolute minimum or the base standards of hardware that needs to be running on a system in order for that software to be installed and used. The software might not be running at its best, might not be its most efficient level, but it will work. These are the minimum requirements, the bottom level of requirements. Then we have recommended requirements. Recommended requirements is the hardware needed for the software to run at its optimum performance. So you would expect that your recommended requirements are higher than the minimum requirements. What I mean by this is it might only need 2 gigabytes to run, but Windows 10 will definitely run better if you had 10 gigabytes of RAM. While 2 gigabytes will work, 10 would be better. 2 would be the minimum, 10 would be the recommended. Now let's look at some specific examples. Again, we're using our top 3, Windows 10, Catalina, and Ubuntu. With the processor, Windows 10 requires a 1 gigahertz processor. Quite low level. Ubuntu requires a 2 gigahertz dual core processor, which is slightly better again. You'll notice that I've got a gap here in macOS Catalina. And these gaps are not because I've failed to complete the slides, but because for macOS operating systems, they do not give you the information about processors, graphic cards, or display requirements, because you are physically restricted to using Apple devices. Instead, they'll say things like, if you have a 2013 MacBook Air or newer, it will work. So they don't give you the specific processing requirements. When we're talking RAM, Windows 10 for a 64-bit version can handle only 2 gigabytes, as can Mac. Ubuntu, however, requires at least 4 gigabytes for it to run. Minimum storage requirements. This is your hard disk. Windows 10 will work with a 32 gigabyte drive. Mac can work with a 12.5 gigabyte drive, Ubuntu with 25 gigabytes. This is what's needed for the operating system to be installed and to run. You probably won't have any space left to save files if you use these minimum requirements. So if you wanted to be able to save things, obviously you would need bigger storage. You'd be very hard pressed to find a hard drive that small in the modern day. Again, graphics cards, there are requirements there, and display requirements. Windows 10 can actually still run with an 800 by 600 display, which is quite a small screen. macOS Catalina, again, is restricted based on the model of hardware from Apple that you've purchased. And Ubuntu needs a minimum of 1024 by 768 display. It will not work on those smaller screens that Windows is able to use. Now, when we think about the scenario of a client wanting to upgrade their existing operating system to a new operating system, we need to consider how is this upgrade going to impact their business operations. Firstly, the data on their existing system needs to be backed up and stored securely before we do anything. We don't want to be responsible for wiping the data from the client and them losing years worth of work. If we were to do that, imagine the disruption that would have to the client's operations. They would have to recreate all of their files or go back through printed versions of their files and scan them back in. The second thing, after we've upgraded to a completely new system, the hardware may actually still get wiped. And so we use this idea of data migration to bring all of that old data back across and into the new system. We migrate it over. Next, we need to think about when do we actually do the installation? At what time of day? And the answer is simple. You need to do your installation at a time that suits the client. And the client is usually going to pick a time that is considered to be off-peak. This is a time when they are not busy at work using their computer. So it might be at night time, it might be in the morning before they've started, or it could be during their lunch breaks. It's your responsibility as the IT worker to liaise with the client and to agree upon an appropriate time. After the upgrade has happened, we then configure the automatic updates so that future upgrades happen automatically to minimize further disruptions. And again, this could be as simple as setting the updates to search at 5 p.m. for new updates and to install them overnight so that the next day they'll be ready to go. Lastly, we think about what can we do to prevent future issues. What sort of maintenance can we do to a computer that's going to make sure that we don't have these future problems? We call this preventative maintenance, and you should schedule preventative maintenance to happen regularly. This can include things like regular data backups, defragmenting your disk drive, cleaning up the actual disk and making sure your files are stored in a neat and orderly way, removing old files that are no longer needed, and all other sorts of regular ongoing things that you can do, such as physically cleaning your computer as well to prevent damage. The final thing we need to think about when we're thinking about minimizing the disruption to the client is what alternate procedures are there. While we are taking over their computer and installing the new operating system and setting that system up for them, is there a replacement device or an alternate device that they can use to continue getting their work done? Now, when we're thinking about this installation process, there's a few things we need to consider. Firstly, how do we want to manage the power on the computer? Secondly, have we got all the peripherals set up, installed, ready to go, and do they work? And this is where we start thinking about this idea of device drivers. Now, a device driver is not someone that sits in a car and takes you from one place to another. A device driver is a piece of software that makes the hardware work on your computer. Disk preparation, what do we need to do to the drive during the installation process? What file system are we going to select? And how are we going to migrate the data across? Let's look in detail at power management. Hibernation is a specialist terminology. When you're using your computer is just simply on. But when you are not using your computer, there are things that you can do to minimize the power being used. This is particularly important if you're using a laptop that runs on a battery. To save power, hibernation is available. This is where your computer, as it is, with the Chrome windows open, with Spotify open, with Microsoft Word document that hasn't been saved, all of that information gets saved to a spot on your hard drive and your computer completely turns off. Screen turns off and it powers down. When you press the power button to load your computer back up, the computer loads your existing state. So Chrome will open, so will your Microsoft Word document, and so will Spotify, just like you left it. The benefit of hibernation is because your computer power is completely turned off, there is no power usage happening at all. The second one I'll talk about is sleep, standby, and suspend. Sleep, standby, and suspend are same terms for same processes. This is where the power that's being used is minimized but not eliminated. What happens here is your RAM is still working. Your files are still sitting on your RAM, your processor is still there, but it doesn't turn your computer off completely. It turns off your hard disk, stops that from running, and it actually gets your processing unit, your CPU, and throttles it down, turns it down so it uses the minimum amount of power possible while still keeping your computer ready for use. During sleep, standby, and suspend, if you move your mouse, it usually reactivates and instantly it's ready to go. With hibernation, you have to wait for your computer to reload back up and bring back that previous state. So hibernate reloads slower than sleep, standby, and suspend. A sleep timer is a setting that indicates how long will it take for your computer to go to sleep, and after it's asleep, do you then want it to hibernate? For example, on my laptop, after 5 minutes, my computer screen will go to sleep. Then, after another 10 minutes, it will go into full hibernation mode, where all of the information is saved to the hard drive and the computer powers off to save my battery. The very final thing you'll see there is Wake on LAN, or WOL as it's sometimes abbreviated. This is a really special low power mode. Effectively, your computer is turned off, but there is still power provided to the network card. And it's constantly looking for or waiting to receive a signal over the network. And if it receives this special token, which is the Wake on LAN token, that signals then your computer turn on, and it uses that signal over the internet, or over the network, to activate your computer and to turn it on. So you can actually have your computer actually turned off, and you can turn it on remotely using Wake on LAN. So that's power management in a bit of a nutshell. Let's look more at some disk preparation information. We've already spoken about backing up our computer and the importance of that. So we'll talk about the formatting process. Formatting is the process where we set up what is the file system structure that we want to use. E.g., do we want to use FAT32? Do we want to use NTFS? In order to format a hard drive, you need to wipe all of the information that's on it, so it clears all of the information, and you reset the system. You cannot just change from FAT32 to NTFS without wiping the information. So that's why it's really important to back up the drive. We then can think about partitioning. Partitioning is where you get the drive, one single hard drive, and you pretend that it's multiple. You break it into smaller parts. This way you can have one part that's used to store your work files, one part for your gaming files, and you could even have another part to run a separate operating system. So your computer acts like there are 3 separate hard drives, when actually in fact there's one, and it's only virtually split up. The final thing there in the preparation of the operating system is starting the installation. You press the start button, it then goes and starts loading the boot information for how to install the operating system. It writes it to the hard drive or to the solid state drive so that the operating system can install. Your computer will restart, and then it will load from the newly installed and newly formatted drive. This is our last slide here on installation option, and we'll be familiar with all of these after our pracs. But there are a couple of different ways that you can actually install an operating system to your computer. The first is using boot media. Boot media is where you get a USB drive or a hard drive or a CD drive. You put it into your computer. When you restart the computer, in the boot menu, you select which boot media you would like to use. So instead of loading the operating system from the hard drive, it can load a temporary operating system from a USB or from a CD drive, which then gives you the ability to install that operating system back on the hard drive. You can also install operating systems from a recovery partition or from a recovery disk. You can also install an operating system by mirroring an existing image. And lastly, by using network servers, where you may have an image set up on the network, you download it and copy it across to your own device. So that's the end of installation options for an operating system, and I now look forward to running some pracs with you on all of these different options. Thanks very much for your time.